So in this video, I'm going to solve another question on chapter 9. So in this question, we have a circular disc, and then the air flows and pass through the disc. And this is the velocity of the air is 6.9 meter per second. And what else we have is the pressure distribution on the front of the disk, and we have a function of that, which is the function of the pressure, uh, which is based on the radius of the disk, and also we have a uniform pressure at the back side of the disk. So now the question asks us how to determine the total drag force on the disk. So we know that the drag force is due to the pressure effects. So it means that the viscous effects cancel on the each side of the disk. Now, if we consider that definition, and if we use the definition of the drag force is because of the pressure distribution on the disk, so when we multiply pressure by the area, we're gonna get the force, right? So now we have the pressure distribution on the disk, so let's write it down. So the pressure distribution is, and also we have dA here, right? So we're gonna write down the dA, which is going to be 2 pi r times the pressure distribution minus the pressure distribution right at the back side of the disk, which is P2 times the area, right? And if I just put the value for R, and also we have the pressure distribution, which is 25 minus 100 times R squared. So I'm just going to substitute that in this equation, right? And now if I take the integrate, I'm going to have 2 pi times 25 over 2 times R squared minus 100 over 4 R to the 4, which is from 0 to 0.5 minus the pressure at the back of the disk, and this is what we are going to have. And now from here, I just going to substitute the values for the R, for the pressure at section 2, and the rest of the values that I need to have here. And be careful that P2 is minus 20 Pascal, so don't forget about the sign. I'm not doing anything fancy, just substituting the values, right? And then from here, the drag force is going to be drag force is going to be 25.5 Newton, right? In section B, it said that calculate the drag coefficient for the disk and compare its value with this figure, right? So we have the coefficient of drag. This is the formula. Coefficient of drag is drag force over half of rho the times free stream velocity squares over the area, right? So this is what we have for drag force of, sorry, for the coefficient of drag. And we already calculated the drag force, which is 25.5, right? And then I'm just substituting the values for density, velocity, and radius. So this is the coefficient of drag that we have. And we also can just calculate the Reynolds number to compare it to the, using the figure 9.29. Let me just get the value for Reynolds number. So this is what we get for Reynolds number. Now let's use the figure 9.29. So now if we are using the table 9.29, so we can see that for the thin disc, we have the drag coefficient of 1.1, right? Which is approximately what we get also with the calculation right here. So this is another way to use that figure to find out the coefficient of drag.